extremes of our solar system. At one end, the sun blazes at 10,000 degrees. Its radiant heat dissipates rapidly until after 1 billion miles we find the outer planets, Uranus, Neptune, and Pluto, at temperatures of more than 300 degrees below zero. Here on Pluto, the distant sun glows but faintly over silent landscapes of frozen gases and lakes of liquid ammonia. Here, an Earthman would succumb in 15 seconds from the complete lack of oxygen, his body being solid in a few minutes. Moving nearer to the sun, we find Saturn. In spite of its majestic beauty, the poisonous atmosphere of ammonia and methane gas would be a death trap. Jupiter is closer to the sun, but is still intolerably cold at 200 degrees below freezing. Like Saturn, its air is poisonous. Again, man would quickly suffocate from lack of oxygen, his frail body torn by dense gases, blowing in gales up to 400 miles an hour. These outer planets are far too cold and hostile for life as we know it. On the other hand, if man should visit Mercury, the planet closest to the sun, he would find it much too hot for life to exist. Mercury is a small and airless world, with one burning face turned always to the sun. Man's blood would boil in this vacuum, and his lifeless body would be incinerated in seconds. As we move away from the sun toward the Earth, we enter the temperature zone favorable to life. In this golden zone are the orbits of Venus, Earth, and Mars. There may be life on Venus, but we know very little about our sister planet, for her mysteries lie shrouded beneath an impenetrable mantle of dense clouds. Beyond the Earth, at the outer fringe of life's temperature zone, is Mars, the third planet in our solar system where life could exist. Even though scientists think Martian conditions are severe, they believe that if man journeyed to Mars, he could survive here with moderate protection. He would need his own oxygen supply and some sort of protective covering. But life could be almost normal within pressurized houses and pressurized cities. Today, as we face the serious problems of overpopulation and depletion of natural resources, the possibility of Mars becoming a new frontier is of increasing importance in our plans for the future. What evidence do we have that Mars is a planet where life could exist? To answer this, we must search through the archives of astronomy. Here we find that from earliest history, Mars has been an object of great interest. To the ancients, Mars was only a wandering bright light in the sky. It was the blood-red symbol of war. But to Galileo, the first man to see it through a telescope, Mars appeared as a glowing red disk where sometimes a shadow appeared on one side. As telescopes improved, astronomers began to notice mysterious markings, which they carefully recorded with drawings. Each decade brought new discoveries. It was found that Mars rotated on its axis like the Earth. It had white spots at the North and South poles. The dark areas seemed to be permanent shapes. In 1781, astronomer Sir William Herschel, using a telescope of large proportions and increased accuracy, discovered that the white polar caps of Mars increased during the Martian winter and decreased with the coming of summer. By 1840, interest in Mars had mounted to the point where the first crude map was attempted outlining the areas thought to be continents and seas. Then, one clear night in 1877, Giovanni Schiaparelli made an historic observation. He saw the surface of Mars crisscrossed with a network of lines which seemed to connect the dark areas. He called them canali, or channels. The American astronomer Percival Lowell was so intrigued by Schiaparelli's findings that he built an observatory in Arizona dedicated primarily to the observation of Mars. Over a period of 20 years, Lowell and his assistants kept a nightly vigil whenever Mars was in the sky. A very important clue in the Martian mystery was uncovered by Lowell. When the polar caps increased in the fall and winter, the dark blue-green areas turned a brownish purple and grew fainter. With the coming of spring and summer, the polar caps receded. The blue-green areas gradually appeared again. This led Lowell to believe these regions must be great expanses of vegetation, irrigated by the melting snows of the ice caps. Lowell theorized that this was accomplished by the large network of canals. He realized that it was impossible to see a clear picture of Mars because of the disturbing movement of the Earth's atmosphere. Nevertheless, he maintained that the canals appeared too symmetrical and well organized to be accidental. Lowell concluded Mars to be a dying planet inhabited by intelligent beings who, with their giant network of waterways, were fighting a desperate battle for survival. Many of Lowell's interpretations of what he saw on Mars have been questioned by other astronomers. Some observers claim that the canals are only optical illusions, which if seen up close would break up into natural formations. There have been other mysteries to puzzle astronomers. Recently, an observer saw a bright flare of light suddenly appear and then slowly fade away. Was this an atomic explosion or a volcanic eruption? Or was it some sort of interplanetary signal? No one can say. In 1954, observers found that a new green area about the size of Texas had emerged from the red desert during one Martian season. Is this a new section opened up to irrigation by intelligent beings, or merely a natural phenomenon? Then there was a peculiar W-shaped cloud that over a period of months formed every day during the Martian afternoon. Was it another signal, or was it only a Martian dust storm? Today in Flagstaff, Arizona, the observatory established by Percival Lowell is actively engaged in a modern program of Martian research. The large 24-inch refracting telescope still plays an important role in solving the puzzle of Mars. A member of the observatory staff for 50 years is the senior astronomer, Dr. E.C. Slifer, who is considered to be one of the world's foremost authorities on the planet Mars.
Whether or not there is life on Mars is pure speculation. Before we imagine our neighbor as a planet teeming with super-intelligent beings and exotic plants, let us first consider some of the facts about Mars that astronomers generally agree on. We know that Mars moves in an elliptical path around the sun, and it takes a little less than 2 Earth years to complete the trip. Since Mars travels almost twice as slow as the Earth, we can only observe the planet close up every 2 years. Mars occasionally comes as near as 35 million miles. We know also that Mars is about half the size of Earth, and its gravity is 1/3 as strong. Like the Earth, Mars rotates, and its day is approximately a half hour longer than our own. It has 2 tiny moons which revolve about the planet at great speeds. Also, like the Earth, its axis is tilted, creating the seasons of spring, summer, fall, and winter. In speculating about life on Mars, we must consider these 3 important factors: its air, its temperature, and its surface features. To roughly determine what sort of air Mars has, we use a spectrograph. This instrument simply breaks the light received from Mars into a band of colors like a rainbow. By analyzing this spectrum picture, astronomers find that the Martian atmosphere is quite different from that of the Earth. It probably consists mostly of nitrogen and a small amount of carbon dioxide with little or no free oxygen. The temperature of Mars is given by the thermocouple, an instrument so sensitive it can measure the heat of a candle 40 miles away. It tells us that the temperature of Mars sometimes reaches a balmy 85 degrees during the day, but drops to 95 degrees below zero in the coldest part of the night. There's a certain amount of guesswork about the surface of Mars. We can see that it's a rosy orange color with patches of darker green. But what causes this coloring, we are not sure. These bright regions could be dry, sandy deserts like our Sahara. Light from Mars is too faint to obtain an instantaneous photograph. An exposure time of at least 1 second must be used. Unfortunately, this isn't fast enough to keep the movement of the Earth's atmosphere from blurring the final photo. For this reason, photographic proof of the Martian canals has never been obtained. With the meager information that has been accumulated over a period of years, astronomers cannot draw too many definite conclusions about Mars. We realize there are probably certain unavoidable errors in our calculations, any one of which could make a big difference as to whether or not there is life as we know it on Mars.
Although scientific evidence seems to indicate that Mars is a cold, desolate world, many scientists today speculate on what the planet might be like if conditions were somewhat different. With a little more water and oxygen than expected, there could be an astonishing array of life on Mars. A totally different sequence of living things following its own pattern of evolution. There may be plant life that migrates in search of richer soil. There may be plants that feed on other plants. Or even plants that feed on themselves. And if animal life has developed on Mars, it too may have taken many new and unexpected forms. There could be animals with heavy insulation to conserve body heat in the sub-freezing night. Or perhaps the bitter surface conditions have driven some life underground to develop in a dark, mysterious environment. If it is true that there are dust storms on Mars, life could have evolved ways of protecting itself.